Then finally, we are going to think about the conduction of electrons and the electric field. Okay. So based on the consideration until now, it seems like electron, it's easier to understand electrons as a wave or as a wave vector of k instead of the sum of the electron with the mass of m. And then here we are going to think about the electron wave with a momentum of h bar k, which corresponds to the wave vector of m times v for a single electron. So when we think about that, the E field, electric field, is applied to electrons, and E field induced force is applied to electrons, the equation motion can be written like m times acceleration, ma equal like m now dv dt, which is equal to h bar the k dt. And then the applied force is E times field E. So looking at this equation, usually we think like the mass of m. So the electron is, the speed of electron is gradually changed by the electric field from this equation. However, looking at this side, h bar times dk over dt indicate once the electric field is applied, the k wave vector of electrons gradually are changing by applying the electric field of force. So we can think like by applying the force to the electron cloud or electron wave, the wave vector is gradually increased in time. However, the speed of electron cannot be infinite. So somehow electron wave must be scattered or stopped. So what make it stop is scattering by lattice or impurity in the solid materials. And when the electrons move around, it's scattered by the lattice or some unknown atoms. That's why the speed is not infinitely accelerated, but it is stopped. So in this case, this can be modified. The equation 1 can be modified. Just simply a little bit. So this is the original equation, but you have to stop by the tau. So this is a deceleration term. So every average time of tau, the velocity is decreased. Oh, by the way, this is a negative, but this is since this is electron case, so it's a positive force is considered. And under the steady state, meaning that for a long-term period, the velocity change in time is assumed to be 0. In this case, the steady state velocity of electron can be described like minus e tau E over M. So the current by this is given by the density of the electron and then unit of E and the velocity, which is equal to M n E squared tau times E. And this coefficient is called the conductivity. And you frequently used as a property, physical property values for each material. And here's some example here, and then please calculate for yourself and how it happens. For typical metals, the VF, which is called the Fermi velocity, is 10 to the 6 meter per second, and the mean scattering time is 3 times 10 to the minus 14, means 30 femtosecond. And each scattering, how much the electron can propagate, and you can calculate by just a product of the VF and the tau. And it's on the order of tens of nanometer level in general case. So with that, in this lecture, we go through how the electrons can propagate, and then how can we think about the electronic state in a solid, and the density of state, and the conduction of electrons.